yesterday's exercises. Okay. All right. Let's get started. Let me share my screen. Okay. So this is what we had learned yesterday about how storage system, what are the various high level components within a storage system. We saw what is a disk shelf. Okay, like this. We saw, how these disk shelves house the various disk drives horizontally or vertically. And we also understood that there is one more component inside the storage system, which is like the brain of the entire storage system, called as the storage controller. And we also learned that there is never a single controller in enterprise class storages. Mostly there are dual controllers. Both are in active mechanism. And there is a way in which, in real time, whatever is written to the memory of one storage controller gets automatically written into the memory of the second controller and vice versa, so as to protect from failures of the controller or of the RAM, in order to protect new data. Okay. And these storage controller have their own software. They are called storage OS or storage system, storage controller operating system. Okay. Each vendor has its own version of the operating system. Today, we are going to get deeper into various topologies of how the storage system can get connected to the server platform or workload. Okay. And here is where we will talk about different kinds of storages and how these storages serve the data. Okay. So the diagram that you see on the left, where it says connect directly. Okay. This was the initial, I would say, design when storage systems were built or architected. Okay. So just understand, in the earlier days, let me just on my camera. Okay. So see, in the earlier days, what used to happen is people first built servers. Okay. Because they thought servers is revolutionary, everything can be done within a server. Okay. And hence, when they were designing the servers, they designed the servers only for a limited number of hard disk slots in them or SSD slots in them. Okay. So any server that you take in the market, you have already downloaded the specification sheets of some model numbers of servers. If you go drill down and see the details of those specification sheets, you will clearly see something called as maximum number of hard disks that can get populated. Okay. Or maximum number of SSDs that can get populated in that server model. Okay. And it also mentions what is the type of hard disks or type of SSDs that you can put inside the server. But essentially, since the number of slots available to put hard disks in them are limited, thus came the concept of external storage systems. Okay. Where all the great minds in the world, they came together and they started designing these external storage systems. Okay. The first kind of external storage system is called DAS. 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 Very simple. Direct attached storage. Okay. No need, you don't need a degree to understand this. Okay. DAS. Direct attached storage. Very simple. Okay. So in DAS, what happens? What you see in this diagram. Okay. On the left hand side. The storage system is directly connected using some cables to the servers. Now, what kind of cables, why those cables, we'll talk later. Okay, but first understand that a DAS, direct attached storage, is nothing but an external storage system which is directly connected using some cables to some kind of ports on the server, so that when the server is up and running and when the storage system is also up and running, the server will not find any difference between the hard disks that are connected internally to it within the chassis versus what is the storage space it is seeing from this external uh, you know storage system that is connected to it. Okay, so that is the architecture or topology of a DAS. Very simple. Direct attached storage so that servers can store more. Very simply, the storage system will be connected using a few cables to certain ports in the server. What are those cables? What are those ports? What is the protocol used? Everything we will learn. Okay, but first understand this architecture. So this is a direct connect architecture or DAS. Then comes networked storage. Network storage means you are not going to connect the storage system to a single server. You are going to make this storage available for multiple servers to use it. Okay, which means directly you cannot connect a cable to a single server from the storage. You have to have a network in between. Okay, so the storage system gets connected to the network, and on the other side the servers also get connected to the same network, and then using certain mechanisms we will make sure that whatever is the storage space we are creating in the storage system, that is visible to the servers. Okay, and here also there are two subcategories. Okay, you can see here it is written. Okay, one kind of connectivity is written as 10G, capital G small b e. We will understand what this is. And then something is written as 16 Gbps FC. Okay, so let us dwell a little bit into this. Okay, so I would like to understand from you, boys and girls, how many of you have ever seen, touched, or worked with a network cable? A network cable. Any of you? Network cable? No? Okay, no issues. So a network cable is also called as an Ethernet cable. Okay, and this E in 10 GBE stands for Ethernet. Okay, now what exactly is Ethernet? It is nothing but a mechanism to allow users or data centers to create something called as a LAN, local area network. That is what we understood on day one, correct? Ethernet is a mechanism, is a protocol, is a standard which is used to create a local area network, LAN. Okay. And these Ethernet cables are nothing but copper wires. Okay, which have connectors on both the ends, and there are actually multiple cables, actually eight small cables which are carrying different kinds of signals inside one big cable. Okay, and together that form something called as a cat 5, cat 6, or a cat 7 cable. Okay, what is this cat? Cat is nothing but category. Category 5, category 6, category 7. These are the different categories of cables. Now these categories will define, okay, how long the cable can be. Okay, how much data traffic can that cable actually handle. Okay, because earlier the data speeds were measured in Mbps, then data speed started measuring in Gbps. Nowadays data speeds are getting into hundreds of Gbps. The fastest Ethernet network switch available in the market today is from a company called Arista. and there are many other competitors also. Each single network port and the cable attached to it can transfer 800 gigabits per second. Can you believe it? Okay, 800 gigabits per second. That's the amount of data transfer speed that you can achieve in Ethernet, okay, today. All right. But that's all network, okay? That's all like allowing connectivity between servers and storage systems or in between servers also. Now, any kind of a storage system that is connected to the Ethernet and will serve mostly unstructured data, okay? Mostly unstructured data. That kind of a storage system is called as a NAS, NAS, network attached storage. Again, very simple, no rocket science involved. Because the storage is attached to a network, it is called network attached storage. Very simple. And the kind of data it naturally serves or it was designed to serve is unstructured data. Okay. Yesterday and day before we had seen examples of what is structured data and what is unstructured data. So unstructured data is basically large files, media files. There is no predefined format in which you store them and there is no predefined pattern in which you access them. Okay, it's there available for anyone and everyone to use it as long as you are the valid user to access that data. Okay, so that's NAS. Any storage that is attached to a LAN or a network and is serving multiple servers or computers in the network for data storage purpose, that is called as a NAS, network attached storage. We'll get into details of it, don't worry. Okay, I'm just introducing the terminologies to you right now. Then you see this also, right? It is written as 16 Gbps, but another two letters are added there, FC. Okay, fiber channel. FC stands for fiber channel. Now here is where I would like to talk about something. Just give me a moment. Let me open up a document. Okay. All right. So we understood that 10 GBE. Okay. This stands for 10 gigabit. Okay. Bit is always mentioned in small b. Okay. Bit is always mentioned in small b. 10 gigabit Ethernet. Okay. And this helps us to form something called as a LAN. LAN stands for, we all know, local area network. Okay. And any storage which connects to a LAN is called as NAS. And NAS stands for network attached storage. Okay. Very simple. Mostly used for serving unstructured, which means large videos, audio, okay, big data, this kind of data. Clear? So this is about this 10 gigabit Ethernet. Okay. Now let us understand what is meant by 16 Gbps FC. Okay. So 16 Gbps FC means of 16 gigabits per second. Okay. 16 gigabits per second and FC stands for fiber channel. Okay, fiber channel. Now, when we speak of fiber channel, right, there are two different kinds of fiber. The word fiber itself. One is called as fiber fiber. Okay, please stress on this fiber fiber. When we talk of fiber fiber, we are referring to physical media. Okay, physical media, which means fiber optic cables. Fiber optic cables. You will see many fiber optic cables are used to connect to internet. Okay. Similarly, these high speed fiber optic cables are also used inside data centers for high speed data transfer. Okay. And you can see the difference in speed. So 16 Gbps versus 10 Gbps. Of course, 16 Gbps is higher. Okay. But at the same time, it is also very efficient. Okay. Now, why it is efficient, we'll talk about it. Okay. And this is where we'll get into the protocol. Okay. And if you notice, when I was writing FC, I didn't write fiber fiber. I wrote fibre fiber. Okay. Fibre fiber. This fiber channel is actually a protocol. Okay. And it stands for FCP, Fiber Channel Protocol. And this protocol is used to develop a special kind of network called as SAN. Okay, where SAN stands for Storage Area Network. Okay, SAN stands for Storage Area Network. Now, what is the difference between a normal network and a storage area network? Okay, SAN. In a normal network, any kind of device can be attached to the network. It can be a server, it can be a laptop, it can be a phone, it can be a Wi-Fi access point, it can be a storage system, it can be a printer, it can be any IoT device, it can be a sensor, it can be a scanner, it can be anything. Okay, anything and everything can be connected to a LAN. Okay, here we are saying that if a storage is connected to a LAN, then that kind of storage we are calling it as a NAS. But actually, any device can be connected to a LAN. Okay. But when it comes to this SAN, any kind of device cannot be connected to a SAN. Okay. It is used specifically for ultra high performance storage systems. Okay. And one characteristic of a ultra high performance storage system is something called as low latency. Okay, latency. Now, what exactly is latency? Latency literally means delay. Okay, latency literally means delay. Okay, now what is this delay? We are introducing a new term here. Okay, let me explain to you by giving a practical example. Okay, and you also can do this while you're doing this. You can open up your command prompt. Okay, just a minute. Let me increase the font size for you all. Where did that go? Man, I forgot where the font size is. Anyways. Okay, let me not waste time on this. So simply there is the option called ping. Okay, ping is a command which is used to understand what is the delay on the network when you're trying to access something. So let me say I want to ping www.google.com. Okay, when I do that, you see a few things here, right? So you see that 64 bytes of data is being sent from my computer here to this IP address called 142.250.183.68. We'll understand what this is. And ICMP is the protocol being used by ping. Okay. And it is sending the packets in a sequence 0, 1, 2, 3, 4, so on and so forth. And then there is something called as TTL, total time lapsed. And then there is another thing called as time equal to. Okay, you see this at the end. This time equal to is nothing but the response or the time it takes for the response of this packet, the 64 bytes packet, to go from my computer to Google and come back. Okay, round trip. And this is measured as you see in milliseconds. Okay, that means within milliseconds, my laptop here is able to reach one of the servers of Google, and it is able to acknowledge that response back in like 17 to 18 milliseconds. Okay, 17 to 18 milliseconds. So this is called as latency. Okay, this delay is called as latency. Time taken for a data packet to be sent to destination and to receive the acknowledgement of the same by the sender. Okay, time taken for a data packet to be sent to the destination and to receive an acknowledgement of the same. Okay, by the sender. So this round trip, okay, is called as latency. Okay, now what is the difference between a SAN and a LAN? In SAN, the latency is measured in not seconds but in milliseconds. Okay, in further high speed networks it starts getting measured in microseconds, and in supercomputers and all it starts getting measured in nanoseconds and picoseconds. Okay, so that's how fast it needs to be. All right, and this is a dedicated network which is connected over fiber optic cables. And inside a fiber optic cable, what travels is actually light. And we all know from our physics classes that light is the fastest medium using which we can transfer information, right? So these fiber optic cables are actually using laser light, okay, to transfer the information, and that is the reason why they become a very low latency network, and hence it is used for ultra high performance storage systems. Okay, and because of this reason they are extremely expensive. Okay, each single fiber optic cable costs thousands of rupees. Okay, in contrast, an ethernet cable you will get for like 80 rupees or 100 rupees. Okay, so it is 10 times, 20 times, 100 times more expensive. Okay, we will learn more about network cables, media cables and all later. Okay, but I'm just trying to introduce these concepts to you right now. One more thing you need to understand here is this protocol. Okay, it is the efficiency or high speed or low latency we are getting, or the we are able to achieve in the data center, not just because of the laser light and the fiber optic cables. Okay, it's also because of the protocol that is being used there. Okay, in high speed SAN networks, this protocol is used, fiber channel network, fiber channel protocol. But in LAN, right, what protocol is used? The same TCP IP protocol. Okay, TCP IP protocol, we understood yesterday that it is a set of rules that is designed to transmit data over a network, right? Now, whenever any protocol is designed, and whenever that protocol is used to transfer data on a network, something we need to understand is what is the efficiency of the protocol. Now, what do you mean by efficiency? Efficiency means how effective that protocol is in transferring the data. So, for example, if I have a 1 gigabit Ethernet physical cable, okay, physical Ethernet cable, okay, then actually can I transfer 1 gigabit per second? The answer is no, you can't. Okay, because this TCP/IP protocol's efficiency, okay, efficiency of TCP/IP protocol is somewhere between 65 to 75%. Now, why is that? Because there are a lot of overheads. Overheads means apart from actual data, okay, apart from actual data, you need additional data, okay, for error correction, transmission, control, okay, these kind of functions. So your data packet, okay, will have all this additional information apart from your actual data. And that is how, when you are actually measuring in terms of how much throughput you're getting or how much actual speed you're getting for your data, okay, it drops down to 60, from 100 to 65 to 75% because of all these overheads. Okay, whereas when you come to this fiber channel protocol, which is used to build high performance, ultra high performance storage systems, here the efficiency of fiber channel protocol is greater than 95%. Okay, why? Very little overheads. Okay, why very little overheads? Number one, because this is not meant to be a general purpose network, right? This is meant to be a very specific network. And hence, your destination systems and source systems are already known. Okay, in a TCP/IP, you don't know. In TCP/IP protocol, you don't know at any given point of time who is going to send what kind of data onto the network. It is absolutely random. Okay, for example, did Google know that I'm going to send a ping request to it like this on the network? Okay, no, it did not know. It is based on my whims and fancies, right? So anybody can send any kind of data at any point in time in the network, right? So hence these extra overheads have been built, okay, to ensure correct data without any corruption is reaching from the designated sender to the designated receiver. Okay. But in fiber channel protocol, that problem is not there because your sender and receivers are predefined. Okay. You already know who the storage system is going to be, what is going to be its ports. You already know what the servers are going to be, and you know which servers are going to be connected to the storage, and hence very little overheads are needed for error connection correction, routing, and things like that. Okay, and that is the reason why the efficiency of fiber channel protocol is greater than 95%. Okay, and it is with a combination of the fiber optic cables, okay, which are using laser light to transfer data, and the fiber channel protocol, you get a ultra high performance, low latency network, which is meant specifically for storage systems. Okay, whereas in a LAN, you are using, first of all, normal cables, normal network cables. Okay, and the protocol being used is TCP/IP, whose efficiency is only 65 to 75%. Okay, and that is the reason why it works. Definitely it works. The entire internet is working on it, but it cannot be used for ultra high performance. Okay, now another factor is cost. This is extremely expensive. Okay, and hence these are used only for specific purposes like space research. Okay, some very advanced AI algorithms. Okay, then drug research. Okay, where extremely high performance is required, this is used and people are ready to pay for it. Whereas this TCP/IP protocol on normal LAN and Ethernet is used where cost conscious people are there. They want the feature, but they are not able to spend that much amount of money. That is where this LAN comes into picture. Okay. Now, any questions between LAN and SAN, and what is the difference between them? Now you understand what is 10 gigabit Ethernet. That means we are talking about LAN. And when we are talking about 16 Gbps FC, we're actually talking about SAN. So storage systems, there are storage systems which get connected over LAN, there are storage systems which get connected over SAN, and there are unified storage systems which can do both. Okay. Any questions? Any doubts? Okay, is it too complex? Any particular term any of you did not understand? Did I go too fast? Okay, no? Fine. Okay, let's move forward now. So now we are going to talk a little bit more about internal mechanisms of a storage system. And from here on, we are going to get a little bit more complex. Yes. Okay. Okay. So yesterday we understood what is a controller, storage controller. We also learned what is a hard disk drive and what is an SSD. And we learned that hundreds and thousands of disk drives and SSDs can be attached together, okay, to make them work together so that petabytes of data can be, written. All right. And we also understood that when petabytes of data are being written, you're not writing to individual hard disks at any given point of time. This storage controller is actually writing to multiple hard disks and multiple SSDs simultaneously. Okay. And how it is doing that, we are going to understand. And this is where we introduce this concept in storage controller called as front end and back end. Okay, front end and back end. Now, what exactly is front end? The name itself says whatever is facing front is front end, whatever is facing back is back end. Just kidding. Okay, that's not the case. In the context of data center and in the context of storage systems, front end means the components which are getting connected to the external world in the context of the storage system. Okay. Now, if you can imagine the storage system to be a one large big computer, whatever data is stored in that storage system is going to be connected to a network using either Ethernet cables or fiber optic cables. And using those cables, you're going to connect to certain kind of networking equipment like switches or routers. Okay. And through those switches and routers, the servers are going to get connected to the storage system to read and write the data. Correct? So, front end is those components within a storage system which allow the servers to get connected to the storage system securely so that they can read and write data. Understood? Very simple. Okay. Very simple. Any part of the controller which is responsible for outward actions or actions required by the external world from the context of the storage only. All right. Those will be called as front end. And all the components that are required to store and protect data on the hard drives in the backend, which is not directly visible to the servers or to the users, those all form the backend. Okay. Now let us do a little bit of drill down. Any questions before we move further? No questions? Okay. Now, what are the subcomponents within the front end of a storage system? Okay. The subcomponents are, it will have front end ports. Okay. It will have processors and it will have memory. Okay. These are the components of the front end. All right. So what is the purpose of the front end ports? These are nothing but the network ports that allow the storage system to get connected to the external world. Okay. These ports can be Ethernet ports, there can be fiber optic ports. Okay. Whatever. However, the solution architect like me would have designed the entire solution, they will decide, okay, what kind of front end ports to be used. Okay. Depending upon the performance need of the customer, depending upon what workload that storage system needs to be served, and depending upon the cost factors also. Okay. So we will take all these things into considerations and we will decide which front end ports to be used. And let me tell you, there is no AI algorithm here. Okay. You have to really understand, okay, that which kind of port will give what kind of performance, and you'll have to understand what kind of networking switches the customer already has in their network, whether they are ready to buy new switches for this purpose or not. And depending upon all these factors, you will decide, or the solution architect like myself will decide, okay, what kind of front end ports we need to keep in the storage system, which means these are configurable. Okay. This is like a custom built hardware. Okay. It is not off the shelf. Okay. There are off the shelf storage systems also, but they are not enterprise class. Okay. Data centers don't use off-the-shelf storage systems. They use completely customizable and configurable storage systems. And hence, almost every component of the storage system inside the controller, the kind of hard disk, everything is configurable. Okay. So the first thing that we configure and we understand is the front end port. How are you going to connect the storage system to the network and how the servers are going to get connected to the storage system? So that is defined by the front end ports. Okay. Then moving forward, this forms the interface to the storage system. So this is where you read and write. But hold on, before we get into the back end, let me tell you a little bit more about the other two things. Okay. Now, all the data traffic that is coming into the front end port, that data, to handle that data traffic, there will be some dedicated processors. Okay. These will be called as front end processors. Okay. And the data, the actual hot data which the users and servers are actually reading or writing, they will first come and land in this cache. Some people called it cache, but in my experience, the right pronunciation of this word is cache. Okay. What is this cache? This cache is nothing but like RAM. It's actually a RAM only, nothing different. They just gave a different terminology. I will tell you later why. Because unlike a RAM, a lot of things happen here. What this cache does, as long as there is power to the storage system, this is like RAM, volatile memory. This cache temporarily holds the data that is being requested by the end users, and it temporarily holds the new data that is being written into the storage system. Why temporarily? Because as we know, RAM is volatile, and if there is no power, the whatever is the content of this RAM or cache will get wiped out. Okay. So the storage has to quickly do something about it. Okay. What it does, we will learn later. Okay. But for now, you understand that whatever data is being read or whatever data is being written to the storage system, temporarily that data will be stored in this cache. Okay. So we understood that there are these three components in the front end of a storage system. One is the front end ports, which are nothing but the network ports using which the storage system gets connected to the network. To handle this data, there are dedicated processors. They are called as front end processors. And whatever data is being read or written from the storage controller and to the storage controller, it is temporarily kept in the cache. Because the cache is volatile, it is temporarily kept there. Okay. Any questions on front end before we move into back end? Any questions? No? Okay. Don't feel shy, boys and girls. If you don't understand any term, please raise your hand or please unmute yourself and speak up. No problem. Okay. We are here to learn. Your learning is the highest priority. Okay. If there are no questions, we will move forward. Now we'll discuss about what are the various components in the back end. Okay. So as you can see in the picture, backend components are the ones that actually form the heart and soul of a storage system. Okay. So the backend components are the one which are responsible to securely and permanently write the data into the disk drives and SSDs. And whenever front end is requesting for any data, the backend should be able to serve it. That's the purpose of the backend. Okay. Now, as we have understood yesterday, every disk drive will have something called as an interface, right? Every hard disk drive will have an interface. Every SSD will have an interface. What is an interface? An interface is nothing but the mechanism using which a drive actually gets connected to the system. Okay. So what the backend has? The backend has a controller which has specific ports called as backend ports. Now these backend ports are not the same as the front end ports. Okay. Their protocol is different, the cable types are different, the connectors are different, the way you connect them is also different. Okay. They are not like your typical network cables. Okay. They are separate cables. Okay. And these separate cables will get connected from these backend ports on the controller to those disk shelves that we saw in the picture yesterday. Okay. And through these backend ports, the controller can reach all these individual disk drives that are connected, the hundreds of disk drives. Okay. There will be dedicated processors for the backend also to run the various algorithms which will be used to simultaneously read and write data to hundreds of storage systems. Okay. Now, before we jump into this cache and everything, any questions on what is front end and what is back end? And no question is stupid. Any question is welcome. Just a recap, a storage controller broadly has two components, front end and back end. Front end will have front end ports to connect to the network and the servers. It will have its own dedicated processors and it will have its own temporary cache, which is nothing but RAM, volatile memory, where all the data that is being written and all the data that is being read is stored. Then we have the backend. Backend again will have two large subcomponents, controller and the drives themselves or the drive shelves. Controller will have its own processor, its own backend port, and it will be using special kind of cables and protocols to connect to the hundreds of disk drives and SSDs in the backend so that it can simultaneously read and write large amounts of data. Okay. All right, now we get into one of the most critical concept in a storage system. Okay, and let me tell you this back in boys and girls, if you have clearly understood how this works, okay, then you have a good chance of mastering storage technologies and you can deal with any kind of storage system in the world. Okay, irrespective of the manufacturer, irrespective of the model. All right. So I require a few minutes of your undivided attention from here on. We are going to talk about this high speed volatile memory called as cache. And cache in a storage system is a defining factor in many things, okay, of that storage system, because every read and every write goes through this cache. Okay. So what happens? Let me, you know, show you. And while we are, you know, talking about this cache, we have to pay attention. Now, we have the servers on the left hand side. The servers are going to either write or read data from to the storage system or from the storage system. So first, let us take the example of a write. So what is happening? Let us say, Renu Shivani, you went somewhere to Ajanta Caves, okay, with your family, and you're taking selfies. And those selfies, you want to upload it to Facebook, Instagram, or whatever social media platform. And the social media platform is running on certain servers like this, what you see on the left. And whenever you are uploading something onto the social media platform, you're actually creating a write operation in the backend. Okay, which means those web pages, those applications, okay, those apps, in order to store your video and content permanently, they have to create a write operation in the backend. So what they will do is, your, let us say your entire video is 1 GB in size. It will break down that 1 GB into smaller chunks, okay, in the memory of the server first. And each chunk, it is going to write separately to the storage system over the network that is connecting the storage system to the server. Okay, so that green square or block that you see is nothing but a chunk of data. Who generated that data? You and me generated that data. But who is writing that data to the storage system? We are not writing. The application which is running on the server, that is writing to the storage system on our behalf. Okay. So every data operation that we, or every action that we do with digital media in our day-to-day lives, it gets resulted in the data center in this kind of a backend operation. Okay, where the workload or the app sitting on the server will break down that entire humongous amount of data into smaller chunks and blocks. And for each chunk and block, it is going to initiate a write operation to the backend storage system which is connected to it over a network. Okay, now this write operation reaches which part of the storage system? Is it front end or the back end, boys and girls?
Ranjan.
Correct. It reaches the front end. Absolutely right. Now, which ports of the storage system will get connected to the storage network? Front end ports or back end ports?
Front end coach.
Correct. Front end ports. Right. And this data, is it going to get written directly to those hundreds of disk drives or SSDs? Or will it first come and hit something called as the RAM or volatile memory called cache?
It
Where it,
reaches cache.
yes, correct. So that is what we are going to see here. Okay. So that data which we took as a selfie, okay, or a reel, Instagram reel, in the backend, this is exactly what happens. Okay. That data, that file gets broken down into chunks or blocks, and over the server, from the server till the front end of the storage system, it reaches over the network, it hits the front end ports. From the front end ports, it comes and gets temporarily stored in the cache of the storage controller. Okay, and after it gets written to the cache, another algorithm, the backend, will kick in. It will read data from the cache and it will write to the storage system like this. And after it has written to the storage drive, only then the storage will give an acknowledgement back to the server or the application or the workload that your chunk has been successfully written. Until then, it will not give an acknowledgement. Okay. Have you understood this entire step by step process? Okay, very simple, right? That whole big video or reel or photo that we are taking and trying to put it on Facebook or Netflix or Instagram or wherever, that first gets divided into smaller blocks and smaller chunks. Each block and chunk travels over the network that is connected between the server and the storage system. It will first reach the front-end ports of the storage system. The front-end port of the storage system will allow that block or chunk of data to be temporarily stored in the cache or volatile memory of the storage controller. From the storage controller, the backend of the storage controller will read the data from that volatile cache and write it permanently to the backend hard disks or SSD drives. After it has permanently written that chunk of data, only then the storage controller will send an acknowledgement back to the application that, hey boss, whatever you had sent to me, I have permanently written, now it is saved. Okay, until then it will not give an acknowledgement. Now this looks to be a big process. It is a big process, but it all happens in milliseconds. It's very, very quick, extremely fast. Okay, in less than a blink of an eye, hundreds of GBs of data are written like this. Okay, now let us understand what happens when we read it. Because after we take a selfie and put it on Instagram, what do we expect? We expect people to see it. We expect people to like it, comment it, share it, repost it, all these actions, right? Now, what are all these actions? All these actions are actually read actions, right? Because content is created, data is already written. Okay, all you need to do now is successfully read that data from the storage system. Okay, and hence, whenever any of these operations are being performed on any of these apps or web portals, okay, you're actually in the backend initiating a data read operation. Okay, now just like how the write operation, the whole big file was broken down into smaller chunks and blocks, similarly any read operation also is broken down into smaller blocks or chunks. Okay, so even though any of your friend sorry might be requesting for your whole video in one shot, the whole video doesn't get transferred instantaneously, okay, to the servers. That whole video is read by the Facebook or Instagram from the storage system, again in blocks and chunks only. Okay, and somewhere this metadata is maintained. Okay, that this file is how many blocks and chunks and where exactly these blocks and chunks are written. Okay, so that will come later. But just understand at a very high level that whenever you are doing any kind of this read operation, that also is broken down into smaller blocks and chunks. All right. And when this read operation happens from your server over the network and hits the front end port of the storage system, it generates, okay, a read request, okay, to the storage system. Just give me a moment, I'll drink some water and come. Okay, there is a small mistake in this animation. Okay, that small mistake is this: when you're reading a data, the data is not written to cache first. Okay, that data first goes as a request to the storage drives. Okay, because cache is a temporary and volatile, storage, right? So there may be chance that the data is already there in the cache, but most of the time the data will come from the storage drive. And what we understood regarding the architecture of a storage system, that whenever any read operation is happening from the storage drives or the storage system, it is not going directly to the server or the application or workload, right? It is temporarily first written into the cache. So even read operation will also happen through the cache only. It will not happen directly from the storage drives. Okay. So this data written to cache actually comes after, okay, the data has been identified as to which all storage drives the data is there in, and then all those chunks will come and sit in the cache. Okay. And once it sits in the cache, from there the data is sent back to the application, whoever is requesting it. Okay. So this is what happens whenever you are reposting, whenever you are sharing, liking, doing any kind of action on the content that you had created, okay, on a platform. Same is the case with your bank account also. You made a transaction, that was a right, but whenever you are doing balance check, whenever you are doing, okay, give me a report, whenever you are seeing your past transactions, or whenever you are applying for a loan, whenever you're applying for a credit card, okay, all those will result in read actions to the storages. Okay. So one question to you all here: typically, do you think reads are more or writes are more typically to a storage system? Take a guess. That's okay.
Right.
Okay, who said that? Can you share your name?
Hari.
Hari, you're saying that writes are more. Okay.
Yes.
Any other guesses? Any other responses?
Sir, based on the data is storing or by it is reading, based on that it will be calculated, right? It is
Okay. Okay. So that's also a fair answer. It all depends upon what kind of data and what kind of storage and application. Yes, that's correct. That's an acceptable answer. What else? Any other response? Okay. Let me tell you practically what happens. Okay. In any scenario, irrespective of the workload, the number of reads are always going to be higher than number of writes. Okay. Always. Again, let us go back to this selfie and reel example. You upload your reel only once. You upload your selfie only once. But how many times are you accessing it? How many users are accessing it? When you are creating your content and you are uploading the reel, only one user is interacting with the application, right? But when you are reading, multiple users are accessing the same data, right? So across the world, any kind of application, okay, writes are going to be lesser than reads. Reads are always going to be more in volume, more in quantity than writes. Let us take the example of your travel tickets. Okay, same case. When you're booking a ticket, a write operation is happening, and it's only you as one user who is generating that write request to the backend storage system through the workload, right? But after you have created the transaction, okay, and the data is written permanently to the storage drives, how many users are accessing it? The railway authorities and the plane authorities are reading your data. You yourself are reading your data. If you have done it through any third party like Make My Trip, they are reading your data. Your insurance company is reading your data. People who are showing you ads, they are reading your data. Okay. So number of users are increasing. number of times your data is being read is also increasing, right? So any given application out there, okay, most of the time, more, I would say more than 90% of the time, reads are going to be higher than writes. Okay. And please keep this in mind. This is a very, very important characteristic whenever you're trying to decide the architecture for a storage system. Okay. Which means always 90% of the time, you have to design your storage system. You have to do the sizing of your storage system in such a way that the reads are getting served more than your writes. Okay. Always that should be there in the back of your mind. Okay. Any questions? No? Okay. So we are moving forward now. Okay. So now we get into a little more complexity. So we understood a little while back that the what are the working mechanisms of a single controller, right? How data comes into a single controller, how the front end will handle it, a write operation, how it will hit the cache, how it will go to the backend, disk drive, and then once it is written on the disk drive, an acknowledgement goes back to the application or workload, and then again, when a read happens, how it is read back into the cache and how that data is served back to the application or the workload. Okay. But in a practical scenario, right, always there will not be a single controller, right? There will be minimum two controllers in an enterprise class storage system. So we have to understand now that if both the storage controllers are connected to the network, okay, and both the storage controllers are accessible to the servers, okay, now how the writing will happen, now how the reading will happen. Okay. So we have increased the complexity of the read and write operations by one more level or by one more degree. Earlier we saw how the read and write operations are happening through single controller, but now we need to understand how the same read and write operations are happening via multiple storage controllers simultaneously. Okay. So whenever multiple storage controllers are coming into the picture, which are going to help to serve read and write requests, they are called as a cluster also. Okay. They are sometimes called a HA pair also. HA means high availability. HA pair. Okay. Two form a pair, right? So HA pair, high availability pair. So two storage controllers are also called a high availability pair. They're also called a cluster. They're also called active controllers. Okay. So all these terms are used, but basically they work in tandem. Okay. They work with each other to together serve data. All right. Now, as and when we are moving into this world where the performance needs and the data storage needs of the human generation is only increasing day by day as we get more and more digitized. Okay. Just two controllers may not be enough to serve the huge amount of data. Okay. And hence came the concept of multi-node or multi-cluster storage systems also, where in a given storage system or in a given storage architecture, it's not just two controllers anymore. You can see multiple pairs of storage controllers. Okay. 2, 4, 6, 8, 16. Okay, so on and so forth. In fact, let me give you an example. Okay, so I will stop sharing now because we will go into the details of it in our next class. Okay, so let me give you an example. This example stems from some of the work that I did for ISRO, Indian Space Research Organization. So ISRO I can't reveal all the details because of confidentiality, but ISRO has something called as ISDN, Indian, sorry, IDSN, Indian Deep Space Network. Okay. What is this Indian Deep Space Network? It is nothing but the satellite network that is used by Chandrayaan, Mangalyaan, and all these other satellites that are there in space to transfer data from space satellites to ground stations across the globe, not just in India. Okay. Now, the requirement was the storage system to be built to deliver 13.5 gigabits per second of continuous throughput. Okay, which is actually huge at that point in time. So I'm talking about year 2011, 2012. Okay, I used to work for a company called EMC, and EMC had sent me to get this done. Now, uh, all the physical connectivity, everything was set up. Just imagine the number of storage controllers that were needed to deliver this kind of a throughput. Okay, any guess? Is it 2, 4, 6, 8? The answer was 44. Okay, 44 storage controllers were required to be connected over a high speed fiber channel network. Okay, to achieve that kind of a throughput. Why? Because see, when the satellites are moving, they are not stationary. The satellites are not stationary. The Earth is also moving. The satellites are also moving. Okay. So there is a very limited amount of time that the scientists get to pull the data from the satellites to the ground stations. Okay. In a given day. All right. Very limited amount of time. And hence, see, the scientists who build the satellite, they know how much amount of data the satellite can store. Okay. And because of the various astronomical calculations, they also know that how much amount of time they will have to download that information from the satellite onto the ground station, okay, which is getting connected to it. All right. Hence, this requirement came that, okay, in order to download so much amount of data from Chandrayaan or Mangalyaan in that day to a respective ground station, this is the amount of throughput that is needed, 13.5 gigabits per second. Okay. And the supplier has to meet this requirement. Okay. And 44 storage controllers were needed to, you know, together work in tandem to achieve that kind of throughput. So I was one of the first civilians in India to have seen the photos and pictures taken by Chandrayaan and Mangalyaan, the first versions, okay, even before it was released to general public, okay. So I cannot disclose the location. These are all dark sites and very secure. We were not allowed to take our mobile phones also. So I used to go from the security. I used to call my wife at home and say that, okay, I'm getting in, my mobile is not accessible. If you have to reach me, you have to call at this number. Okay, so like that. So, so what I'm trying to say here is uh, what we have understood the operations of a single controller, that's fine. But in very practical scenarios, you are never going to see a single controller storage system in the world. Okay, whenever you're working in a data center, you'll always see at least two controllers. Okay, bare minimum you will see two controllers, but more and more, more complex storage systems are coming into play where there are multiple controllers that are going to be there, that are required to serve the data. All right. So yeah, so we are going to discuss about this from the next class onwards, that how multi-controller storage systems work just at the architecture level. Later we will get into the specifics. Okay. So any questions? Any questions? No? All right. So thank you so much for your time today. I told you, some of you yesterday that, yeah, Prakash, I'm coming there. So 18th April is a very special day for me. Yeah, 18th April is a very special day for me because this was the day when I had joined this company called EMC in 2005, back in 2005, and this was a day when I came to Bangalore. Um, Coincidentally, all this today also happens to be the death anniversary of Mr. Albert Einstein. Okay, and somewhere I felt that spiritual connection. Okay, that was I was meant for something else and not just being a trainer. So on that day, I decided that I'm going to work hard for the rest of my life to build an IT company of my own. And yeah, that dream has come true. I now successfully run an IT company. And yeah, so I still remember that day when I was walking into EMC office. I've never in my life seen such a beautiful office. And the moment I stepped in, it was very clear in my mind what I wanted to do there. So a lot of hard work, okay, a lot of sacrifices. So before coming to Bangalore and joining EMC, I used to be a very small time trainer, training in training institutes in Hyderabad. Okay, I learnt the entire .NET suite all by myself, and I used to train people on .NET. But yes, I knew that that's not going to be my future, and I was constantly looking for an opportunity in the data center side. And thankfully, I got through the interview. And yeah, whenever we meet, probably we'll discuss what kind of sacrifices I had made uh, to be where I am today. I'm not saying that all of you need to make those sacrifices, but uh, success cannot be achieved uh, by sitting on a couch and by watching reels and Netflix. Okay, it takes lot of hard work. It takes a lot of courage also. Okay, because you have to do things which others say may not happen, right? Where when I first told my parents that I'm joining a storage company, the first thing that they asked, "Oh, what are you going to store? Meat, fish, or files?" Okay, so the nobody even knew that such storage systems, such data centers actually existed. So yeah, it was difficult to even convince my parents that uh, what I was doing was right. And even my peers at that time, everybody, most of them had got placed in software development jobs across the globe. But unfortunately, I was not good in college, though I was good in my subject, computer science, but I was not good in the other subjects. So yeah, uh, I used to spend sleepless nights learning this technology, what I am teaching you today. Okay. I'm not saying that I have learned it on day one. No, it took me months to understand this. Okay. And all those months, many days, I never used to go home. I used to sleep on the floor in the office. Okay. Early in the morning, the janitors used to come and wake me up. Sir, we have to vacuum the carpet. You please go. So I used to quickly go home, take a shower, eat something, again come back. So like that, days together, weeks together, I have, worked hard to understand how at a component level each of these things work. And I thought after spending almost 20 years learning data center technologies, it's time for me to contribute back to the society by teaching these technologies. And that's what I'm doing. And thanks to you all, you have shown eagerness to learn this. Let me tell you, if you become masters in this, the amount of money that you can earn is limitless. Okay. If you master these technologies, no one can challenge you with respect to your job. Okay. So one more thing I'll tell you. This day, why it is so important is because after this day, 18th April 2025, how many ever jobs I did, okay, how many ever roles I got, okay, I never ever gave an interview. Yeah, that's true. I never ever gave an interview. I was requested to join the other company at the salary which I wanted, not the salary which they were ready to give me. Okay. And I'm not greedy. Okay. I'm ambitious, but I'm not greedy. So I never asked two times, three times. I know what is the market standard, a little above the market standard. I definitely asked. And there have been cases where I was called for in the name of an interview. I was called to a restaurant. We are eating and we are talking. Okay, तेरे को कितना पैसा चाहिए तू बोल तू कब join करेगा. So that kind of a thing. Why? I'm not trying to boast about myself. There are many people like this, okay? Without interview, they're taken in a job because they are the best in what they do. And how they become the best in what they do is by making sure that every day, day in and day out, they are focused on their work. They are always open to learn new technologies. Even today, I spend time learning. Okay. They're always abreast in the respective field. Okay. And whatever they learn, they try to apply in their field of work. Okay. And only then you become one of the best. And that is the kind of dedication and sacrifice that is needed to become the best. But once you become the best, I can, tell you there is no limit to the amount of money that you can make, and people will come running after you to join them. Okay, you don't have to look for jobs. Okay, even till today I get calls from many companies that come and join. I said no, I'm in my own business now. I don't want to work for anyone anymore. I want to work for myself. So after spending 26 years in the industry, I can say this. Can you guys say this now? No, you can't. But after a few years, can you say? Definitely. But for that, every day you have to work hard. Okay. E- every day you have to spend time reading initially. Okay. And then whatever you have read, you have to find way to apply that. You have to practice it. Okay. Just trust me. I failed 28 times doing my first storage implementation. 28 times I failed, but I didn't give up. Okay. 29th time I succeeded. And when I succeeded, I exactly knew where I was, going wrong. Okay. So unless you practice, unless you work hard in applying the knowledge that you have gained, you will not become the best. Okay. So whatever theory classes I am teaching you right now, please find a way to see how you can apply that knowledge in your day-to-day life, how you can practice it. Okay, only then you'll keep getting better. And as and when we are getting into these complex topics, we are going to uh, get into some practicals also later. Okay, just maybe after maybe 1 week or so. Okay, so be prepared to really work hard on the practicals, many permutations and combinations, and that experience what is going to be appreciated. Okay, any questions on what we have learned today, yesterday, or the day before? No problem. Once you are doing your revision and the daily exercises, okay, you if any questions come to your mind, just put it in the WhatsApp group. Okay, I will make an effort to answer you or give you some additional study material to work on it. All right. So thank you so much for your time, boys and girls. Today, this weekend, I'm not going to give you any exercises. Okay, but one thing you do in all these companies, data center provider companies that you only have researched, okay, and I know many of you use chat gpt. Okay, just by looking at your responses I can tell that you have used chat gpt. Okay, no problem, use it, even I use it. Okay, But whatever the result comes, are you in a position to articulate it to anyone? Okay, that should be your skill. And you can only articulate it well if you have understood it well. Okay, so please make an effort to read the data sheets and spec sheets which you yourself have downloaded. Okay, and go to some job portals and see what kind of jobs are published by these data center provider companies. Okay, you will see site reliability engineer, you will see support engineer, you will see L1, L2, L3. These various terms will come. Okay, you will see storage engineer, backup administrator. Okay, many kinds of roles. Okay, so go to LinkedIn, go to any kind of a job portal, specifically search for these data center provider companies, see what kind of you know jobs they are posting, and see what are the qualifications and technical requirements they're asking in their job post. And slowly you will start appreciating you will start appreciating the fact that, oh, these jobs also exist. Number one, these are all jobs are also high paying. Number two, and number three, whatever we have started to learn now, this is what is going to help me to land those jobs. Okay, I'm not saying that whatever you have learned in your college will be a waste. No, definitely not. There will be usage of those coding languages also in this job, but not to that extent. Okay, but whatever we are learning now, they will help you get a job in these data center provider companies for sure. Okay, so thank you so much, boys and girls, for your time. Have a happy weekend. Keep learning, keep practicing. Sky is the limit. Okay, thank you so much. Have a good weekend. See you on Monday.